So, what up, everyone? Today is Tuesday, December the 13th, and we are solving the 13th task. So, we should be up to date with the schedule, more or less. And as in previous videos, we are solving these in the programming language Nim. We are learning Nim as we are doing this. And today we are again looking at some signals. We have our device and we're getting distress signals, but they are not coded properly, they are out of order, and it's our job to code them back to order. Okay, so, and this time, unfortunately, there will be no drawing board. And the reason is that I think, I don't really know how to draw this. That's a simple answer. So let's just have a look at it, right? So we're getting these lists, or we always get a pair of lists. So this is the first pair, second pair, and so on. And what we have to do is we have to compare these lists. And there are certain rules how we compare these. And depending on those rules, it either puts like this is a correct encoding or false encoding. So it just output true or false, basically. And let's go through these rules. They are slightly complicated, but after all, not super complicated. Okay, so we start by comparing each element in the list, sort of like element-wise comparing these. So if both values are integers, then the lower integer should come first. So basically, in the case like we have 1, 1, that's a tie, so we move on to the next one. 1, 1 is a tie, 3, 5. So 3 is smaller than 5, which means that this is correctly encoded. So here they refer to left and right, left being the upper one and right being the lower one, because, you know, why would you need to be consistent? Doesn't matter. Okay, and as you can see already from here the other examples, the item in the list can either be an integer or it can be another list. So let's go through the case where they are both lists. So then, for example, and this is actually already a case, we have these both are lists. So then if we encounter this case, then we just compare the elements of this list and the second value, so on. But if we run out of numbers, then if the left list, so the upper one, runs first out of numbers, then they are in the right order. And if the right is shorter than the left, so the lower one shorter than the upper one, then it's not in the right order. And then we have this special case. So what if the one is an integer and the other one is a list? So they basically do a conversion. We convert the integer to a list of that integer. So we sort of like compartmentalize it. Oh, damn, that's a difficult word. Okay, so let's actually look at some examples. I think always the examples are good. So here, this is actually what we already went through. So we're comparing 1 against 1, 1 against 1, 3 against 5, 3 is smaller than 5, so this is in the right order. Okay, so now we're comparing this against that. So first we have an array with the element 1 in it, and then, or the integer 1, and then the same case here. So when we unpack these, it's just one versus 1. And now these are also happen to be that these lists are of the same length, so we are indecisive in this case, so we have to move on. So then we compare this against that. So now we have to convert 4 into an array with the number 4 in it, so now we can compare two lists, and now again compare them element-wise, and now 4 is larger than 2, so yes, they are in the right order, and so on and so on. Here, for example, we have a case of different length, so 7 versus 7 versus 7 versus 7. At all times we are indecisive, but then the right one runs out of items, so we are not in the right order. Okay, so hopefully you understood how this works. For me, at least, it took a few examples to sort of like understand the logic, but I think let's just start coding and then let's see what happens. Okay, so we get this. So we get that and that. And now these are, of course, of type string. So now the $1,000 question. how do we parse this? So I thought about it for a while, and we can parse this for sure, just manually. It's quite cumbersome. I don't know, maybe it would work. Um, what we can't do is something like, for example, in Python you have eval, and then you can evaluate some sort of like expression like this, for example. So this actually, and we can, I think it's, what's it called? It's called something like, so, okay, so this works. So what we can do is we can this way we can parse sort of like a string statement into code. What we would like this string to like automatically become an array. That really won't work. First of all, this string as such is not valid Nim code. We would have to do anyway some manipulation. And second of all, and this is like the main reason, is that in Nim you can't do this with a runtime value. So Python is an interpreted language, and you're anyways doing stuff like you're basically compiling it as you run it. But in Nim, since we're like, it's a compiled language, so we can't insert at runtime any like arbitrary like strings and sort of like evaluate that stuff as code when we run the program. And because this text file is something that we read in, so it's something that we like, it's evaluated at runtime. We could of course read the entire input just as a string as part of the program, like that would be kind of wacky. We could do that for sure, but I'm thinking that's not the right approach. So what I think though, so now a lot of talk about what's not the right approach. So what is the right approach? Well, in my opinion, in my humble opinion, the right approach is to realize that each row is actually valid JSON. So we can do import, and that we can of course parse in Nim. So now this becomes a sequence of JSON nodes, and then we can, for each of those like things within, we can again get the elements in there and see like eventually what it is. All right, so I have encountered a problem, and I will show you what that is. So now if we just run it simply, so now we can see that I've changed the order of this a bit. So this is the thing that we are just looking at, and we're going through it. Basically, we have this validate function, which basically does nothing, just like takes in these, then we'll look which one is the shorter, and then we start looping over these two arrays. So now we are echoing the first here, the echoing first elements of both the left and the right array, and then we're echoing their type. And as we can see, their type is JSON node, and then same for here. So everything is just JSON node. So when we want to do this comparison based upon the type of this underlying thing, we have to convert it from JSON node to something, yeah, which we can use in Nim, like some like data type in Nim. So now we see. So okay, the first two values are set to 0 because the first two ones are not integers. The first two ones here, they are arrays, and only this 4 is actually like returns the actual integer in it. So what happens here is that if we're trying to convert the thing to an integer and it's actually something else, it doesn't return an error, it returns a default value, which in this case is 0. But how can I check if something is then actually an integer, which is 0, and if something is not an integer, because they both return 0? So the crafty hacker that I am, I'm taking use of the function overloading feature of Nim in a very, very hacky way. So what I did is I went to the JSON library and I copy pasted the getInt function. And here we have the default value, which we can override. And I override it to 999, as beautiful as that. So now, if the underlying thing, which we're trying to convert to an integer, is actually not an integer, then we instead of returning the integer 0, we return 999. And I quickly checked, so we have no 999 in our input file. So we yeah, hopefully we don't get any problem because of this. There are definitely zeros here, so 0 would definitely be more problematic in this case. So let's check for like the first case, maybe like the easiest one, at least in my opinion, is that if both are basically sequences. So if left at index I dot get int, if this returns 999, where is 9? There. And if right at index I dot get int returns oh my god, this already feels so stupid. Okay, so if they are both, if we're trying to convert them to integers and this integer conversion fails and it returns the default integer, which is 999, and we deduce that they are both sequences, then we have to do a recursion. So this is a bit tricky, because now what we have is like the case that the left is an integer and right is a sequence. And what we would need to do is var res equals validate, and we would need to pass in 2 JSON nodes. So, and that's easy for the right one, because the right one is just like a JSON node, it's a sequence already. But the left one is now an integer. So now basically we would like to artificially, we would like to wrap it again in an array, but we're not working with arrays, we're working with like these JSON nodes. So we would need to wrap it in something that is like, yeah, basically, I don't know, like the array, like the JSON node representation of an array or something like that. And I think I have the solution. So what we can do is, let's do like a fake node. Let's call it like a fake JSON node. And then we can use this operator like that in here. So, and this should take any nim object, nim data type, and sort of like wrap it in a into this JSON node. So now, if I'm thinking this correctly, we can simply have an array which takes in this item, so left I, and let's not forget, now we have to actually get the integer from there, like that. And now we can pass this in here, fake node, like that. So we should, I think, have a way of like going to the next one. I think that's the problem here. So let's option bool, just like that. No, it should be in brackets like this. This should return none bool, and this should be the other way around, because if we evaluate something, where is it? Like that. Yeah, because if we've evaluated them and all of the items, and they have all been equal, and we have been undecisive, we should have a way of handling that. So, and then now here, every time we recurse, we actually have to check that as well. Yeah, that's what's wrong, because then, yeah, it was just sending like its parent item back in again. Okay, so the actual question was, we should keep track of the things that are already in the right order, so everything that returns true from here, and then each pair has an index. So that's basically just like the first one has index 1 and then 2 and then 3 and so on. So let's just look it up for concreteness. So this is index 1, index 2, index 3, and so on. So the question is, what are the indices of the things that are in the right order? So in this case, 1, 2, 4, and 6. And what's the sum of those indices? And that's what I'm doing here. I'm just like checking if that returns some true. And if it is, then just like add its index, and we can enumerate like this in Enum, if you remember. Very nice. And then we put it in the sequence, and then then we just add them up. And when I run this magic, we get the same thing. And now time for the real test. Input.txt. We run this, and then we get quite a large number, but still conceivable. Not that I would have any idea if this is a conceivable answer or not. Submit, and yes, we get 1 gold star. To the next one. So now on to part B. So remember, in the last part we compared these packages. Let me pull them up, like these pairwise. And then the question was, are they in the correct order? So is, for example, so the question is sort of like, does this one come before this one? Is this sort of the correct pair to have? And now, and we just got like a boolean and stuff like that. So now what we do is we need to add 2 more packages to our list of packages, and then we have to sort them in such a way that like it always returns true. So for example, comparing these two, so should this one come after this one, should return true. Same for this pair, same for this, same for this. So basically what we're doing is we're doing sorting. So this shouldn't be too difficult. We just have to find a clever way of implementing the sorting logic of this. So let's do that. So let's start. I've added just like these 2 additional ones that we needed there, and then we're gonna have our proc comparator. Okay, and we're gonna take in 2 things, the same thing that we have here. So we're gonna take in left and right, both are JSON nodes, and then we're gonna return an integer. And now what we're gonna do is we're gonna say if validate left true equals sum true, then we're gonna return 1, else if validate left, oh, that's actually wrong there, right, of course, right, and then right equals sum false, then we're gonna return -1, and else we're gonna return 0. And so now we get let's print this more beautifully. So let's not do that. Let's do for I in all packages echo I, and let's of course clear the terminal first. Voila. Let's just do var lol because we are mature. Sequence of int. And then here we want to do lol.add I. No? Oh, no. So no, we don't want to add I, we want to add index. Whew. I was already worried that I have to do some magic tricks with data types or anything like that, but fortunately I did not have to do that. So echo lol, and we get, and exactly, the indices should be added with 1, because here it starts with 0, but in our assignment it starts with 1. So perfect. Let's change now this to the input.txt, see what we get. And now let's not open the Python REPL. Let's open the Nim because we are practicing on how to use that. So those two multiplied together, This comes out to something like that, and we're waiting, and yes, we get 1 gold star. Awesome. That felt really good. How can we exit this? Is like quit? Yeah, like that. All right, so part B, not that difficult if you knew about changing comparators. Otherwise I think, yeah, this is like standard stuff that should come up in a basic Googling. So if you Google, not that difficult. What else? What did we learn about Nim itself? So working with JSON objects in Nim, maybe, how should I say it? It hasn't been the most pleasant experience, but I think in cases like this, it's sort of like, how should you say it? With overloading functions, you can sort of say like, hey, if you don't like the API, just override the functions and make them work in the way that you like. But then on the other hand, that can become a lame excuse for actually writing a proper API in the first place. And yes, this isn't, maybe I should rewrite this actually, not to be like this. So now that I learned about optional, I could actually maybe change this default to like some option and make this get int actually return like an option. Should we try do that? Let's give it a try. Too excited. I don't know why I didn't do this in the first place. So this was actually a lot easier than I like. Why did I go with this 999? Like that's arguably that's equally stupid as just returning like 0 as the default. But hey, who knows? So yeah, actually it was pretty straightforward just to like wrap this in like an option integer, and then we return some integer and set the default to none of integer. And now of course here we have to take that, we have to unwrap the potential sum value that comes out of there. And I have no idea how to unwrap. So why can't I? Okay, yeah, probably because I had to do it on both. So I just have to put an additional get there. So that's how you would do it. So let's do here as well. Oh no. Dot get. So the dot get unpacks it immediately. Okay, so we learned something about Nim today. This is actually quite a nice feature. I think in general, sort of like Nim has also a nil value representing that. Here actually say the absence of values often represented by nil, but it's not always a good case. So they have this, yeah, option enum. And after using Rust quite a lot, I would have to say like I have actually gotten very used to like the option enum. In Rust, it's of course like you get stuff like this quite easily. So you have this like huge ... for unpacking the actual value that's somewhere underneath all of those results and options and whatever. But for many cases, like for example, in this case, I so much more prefer getting the like option enum back instead of getting some random default integer that someone just chose. Like this makes so much more sense to me, because with this I'm actually able to understand if the underlying JSON node is actually the integer 0 or if it tried to unpack like a data type that wasn't correct. So yeah, that's my small, I don't know, rant over this. But yeah, we overloaded the function. I'm actually slightly proud of what we did today. So yeah, but enough talking, let's go on to the next one.